I'm Rajasri, Assistant Professor, Department of EEE, working at MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing three-phase dual converter. And here, this is three-phase dual converter, which comprises of two full three-phase converters, which are usually connected anti-parallel. And here, this is converter 1 and this is converter 2. And firstly, these are the phase voltages, and I have already explained clearly in the previous videos how to draw these particular phase voltages, which are 120 degrees apart. So here Y phase will be lagging behind R phase by 120, B phase will be lagging behind Y phase by 120 and R phase by 240. So these are the phase voltages. And then coming to the line voltages. Line voltages, each line voltage are 60 degrees apart, and whereas this particular RY leads R phase by 30 degrees. I have already clearly explained these line voltages, how to draw manually as well as with the help of graph. Please refer my previous videos for the clear understanding, and I have also explained the phasor diagram for these particular line voltages. And now let us check out the output voltage for three-phase dual converter. And here, as I told you, both the converters will be operated simultaneously in circulating current mode of operation, where alpha 1 is equal to 60 I'm taking, and alpha 2 will be obviously 180 minus 60. In that case, alpha 2 is 120 degrees. It should be triggered at 120 degrees. So at this instant called zero crossing, this is zero crossing, and until zero crossing, the thyristors will not be triggered, and even if it is triggered, we will not be able to provide any triggering pulse. So at this particular zero crossing, the thyristors will be ready to conduct. So since our alpha is equal to 60, here I'm supposed to provide the triggering pulse, and once the triggering pulse is provided, RY starts conduction. And this is that particular RY which is actually conducting. And RY phase in the sense, see, this is R which is connected to thyristor 1, and this is the Y phase which is connected to thyristor 6. And this is the path of flow of current through the dual converter during this RY phase. That means thyristor 1 is conducting as well as thyristor 6 will be conducting. As I already told you the sequence for the full converter, it will be usually 6 1, 1 2, 2 3, 3 4, 4 5, 5 6, and again cycle repeat 6 1. So this is the interval 1, 2, 3, 4, 5, 6, and again 1. So this is the sequence of interval how the thyristors usually conduct. And see here, 6 1 is conducting because RY phase is being appeared. And later, how this converter 2, this is triggered, this is output voltage for alpha is equal to 60 degrees, and we have provided this triggering pulse for the converter 1. And how about converter 2? See, converter 2 will be triggered. Let's say, let us check out for YB. See, YB for the converter 1 I am explaining. See here, there is a zero crossing. So we need to trigger YB at alpha is equal to 60. This is 60, this is 30, and this is 60. And we have triggered this particular thyristor YB. So because of which we are getting the output voltage, and this is YB. This is due to YB. And let us check out the waveform for converter 2. See, if this is YB and this is BY, okay, and here this is a zero crossing. This is a zero crossing for this particular BY, and this is 60, and this should be 120 degrees. So we need to provide the triggering pulse at this instant. At this instant, we need to trigger this particular YB. In that case, BY starts conducting, and how long it is conducting? Till here. So this is nothing but your by. Here I am explaining yb. We are checking out on by. So this is by, and this is the zero crossing where this is 60 degrees and this is 120 degrees. So it should start conduction from here, and how long? For a period of 60 degrees, only for the period of 60 degrees. So this is your by. So by will be conducting. As I already told you, each SCR will be conducting for a period of 120 degrees and pair of SCRs will be conducting for a period of 60 degrees. So that is how here it is conducting for a period of 60 degrees. And this is the output voltage of converter 2 for alpha is equal to 120 degrees. So yeah, let me check out the waveform for the other so that it will be clear for you. See here, I am explaining RY phase. RY phase for converter 1. Converter 1 in the sense this is a zero crossing, this is 30, this is 60. So we need to provide the triggering pulse for RY phase at this instant. So that is the reason here it starts conducting how long? Till RY is present. So this is your waveform RY. Yes, this is RY. And this is the output voltage for converter 1. Whereas for converter 2, let us see for converter 2, this is RY, right? And let us check out for YR. And for YR, this is the zero crossing, and we will have to provide the triggering pulse for YR at 120 degrees. So this is 60 and this is 120. That means we will have to provide the triggering pulse at this instant so that it starts conducting for a period of 60 degrees. Right. So this is YR. This is your YR. So during YR phase, which two devices are conducting? See, here Y is connected to T3 load and R phase T4. So here T3 and T4 will be conducting. This is how we will be getting the output waveforms for V02, which is exactly reverse to that of the first case because it is connected in anti-parallel. And if you see, converter 1 firing angle is 60 and whereas this will be fired at 120 degrees. So this is the resultant waveform. If you compare these two, we will be getting such kind of the resultant output voltage where VR resultant is equal to V01 plus V02. VR is equal to V01 plus V02. Similarly, let us check out the formula. For full converter 1, we have 3 root 3 Vm by pi cos alpha 1, which is equal to 3 root 3 Vm by pi cos alpha 2. And here both gets cancelled. Cos alpha 1 is equal to cos alpha 2. Alpha 2 is equal to pi minus alpha 1, where alpha 1 plus alpha 2 is equal to 180 degrees. In that case, alpha 2 will be 180 minus, as we know, alpha 1 is equal to 60 degrees minus 60. In that case, alpha 2 should be triggered at 120 degrees. That is how. The coming up lecture, we will be seeing AC voltage controllers. Thank you.